A pretty big quorum. Thanks everyone for joining the Collaborative Analytics weekly call. We're going to get started in a second. We have a pretty packed agenda for today. This meeting is being recorded and we'll send out meeting minutes as usual afterwards.
Great, thanks, Usman. So welcome everyone. This is week 5, and I think it's worth noting just how much progress we've made over the last few weeks. And I really want to thank everyone for their enthusiasm and willingness to contribute where you can. It's been just a fantastic outpouring of support. So I want to acknowledge that the fantastic progress we're making is due to everyone here. So we do have a rather packed agenda. I'll do just a few brief updates, but primarily today's conversation will focus on a demo that's been prepared. We've had our first successful transfer of data from Washington University in St. Louis, and you'll learn more about the motivation for that, specifically a demo that's been requested by the NIH to show that indeed what we have is not vaporware, that this is a real platform with real data, and we want to be able to showcase what we can do. And so we're going to have a brief presentation from Palantir, who's been just a tremendous partner in helping us put this together. Last week we had a presentation from Andrew Williams about Odyssey and the many resources that are provided by the community. We thought it'd be important to take a bit of a deeper dive to study the OMOP common data model specifically. So Claire Blackadder from Johnson & Johnson will provide a presentation on that. And if time, I'm hoping that we'll get an update from Dave Eichmann and Warren Kibbe on the platform and dashboards front. This is a similar slide like this was presented last week. You'll notice the addition of a new work stream. This is synthetic data work stream. Previously, that it was kind of within the umbrella of collaborative analytics. Has now been broken out as a separate work stream being led by Philip Payne from Washington University and Atul Butte at UCSF. So I suspect they'll be having calls and opportunities to learn more about their synthetic data work stream. As a reminder, this work stream is comprised of different subgroups listed here. Encourage you to join their meetings. You can click at the top here. There's a link to join any of these work streams or subgroups, and the times of the subgroup meetings are listed here and who's leading them. I want to provide just a brief update on the tools and resources subgroup. There's been some activity there with respect to natural language processing. I think we can all appreciate that the structured EHRs are not fully capturing all the information we might want to study, and that we should also be thinking about opportunities to extract information from clinical and textual notes. So there is some progress in being able to develop a coordinated approach to this. This is so Andrew Williams has been helping coordinate this activity, as well as Hongfeng Liu at the May Institute, who's a world-recognized expert in clinical NLP analytics. So the immediate priorities will be to focus on shared pipelines that can be applied in a federated manner. So N3C is not set up to intake notes at this time. So this will need to be done in each of the sites, and we're hoping to have this done in a standardized way, as well as to facilitate some of the ETL activity across the other CDMs. So we believe that those are the important first priority activities for NLP, and there'll be other downstream uses that are listed here as well. So if you're interested, please contact Rafael Fuentes. His email is shown here. You can get signed up on that listserv, and I suspect this will be integrated into our onboarding at some point soon. You can also just join the tools and resources group through the onboarding process to get plugged into the NLP activity. Okay, just wanted to point out that this NLP opportunity, this was shown last week. Just wanted to include it here in case anyone is new to this presentation. a quick note about the platform training, the Palantir training schedule. So we send out a note. I just want to provide a little more information on that front. So the training has been temporarily paused. And the reason for this is we've had, due to the request to provide an NIH demo, the ingestion of our first data set, we've been a bit overwhelmed and been able to do everything simultaneously. So we decided to put a brief pause on some of the training while we're able to complete the ingestion of our first data set and develop our first analytical workflow to demonstrate how this data can be used. We expect to resume training very soon, and we will have a process through the N3C website for those that are interested to be able to register your interest and to be able to sign up. So I really hope that we'll be resuming our training schedule very soon. Okay, so let's move on to the demo portion. As I said, this is motivated in part by requests from the NIH leadership to demonstrate what this platform, the state of the platform, and what we hope to be able to do over time. So we're starting to make some renovations into the platform itself. For those that have been granted an account, this will now be what you see in the homepage. Actually, I'm sorry, this is not quite live yet, so it'll be published shortly. But we are starting to rebrand and redevelop the system according to the N3C needs. And so I think with that, we're going to hand it over to Andrew Gervin at Palantir, who's going to walk us through the first workflow analysis. Andrew, are you there?
Yeah, Nabil's actually going to start.
Oh, Nabil, great. Okay.
Oh, yeah, cool. Hi, everyone. So just firstly from the Palantir team, thanks to everyone who came to the trainings. We really enjoyed interacting with everyone and hope that everyone got some value out of them. So we've been pretty hard at work kind of getting things spun up. And as Justin mentioned, we've ingested the initial batch of data from WashU. So if I share my screen very quickly, I'll just kind of take some of the skills that everyone learned from the fundamentals training and show you an applied example of that. So assuming that everyone can now see my screen and kind of see the homepage as it currently exists, this is actually the pipeline for the data that's been brought in from Washington University of St. Louis. And so I just wanted to kind of show this graph because we did this in a kind of theoretical way in the trainings, but now it's very, very much real. So what you're actually looking at here on the left, you can see these boxes represent the original LDS that was ingested, which as an admin, I'm able to see from here. We're generating in the middle of this graph the safe harbor versions of this data. So you can see they're kind of prefixed with the safe harbor prefix over here. And then in the green, what you can see in each of these boxes are analyses that Andrew's going to talk about in a second. So these are tagged green because they were generated in a code workbook. And what this is doing is essentially preparing a machine learning analysis that I will let Andrew talk about shortly. For those who did do the fundamentals trainings and weren't able to make it to, I know there were only a couple of slots. I did just want to make sure everyone's aware of the tutorials in here. So if you do in the Unite environment, just go to the documentation bit. And I do encourage everyone to do the code workbook tutorial as it is very good. And that is actually what the advanced training is focused on primarily. So if you do this, you've already got a good head start. So that was it from me. I'll hand over to Andrew to kind of talk through the model. Andrew, if you're
Great.
there.
Yes,
Awesome.
Thanks, Nabil. Just starting to share my screen here. Is that coming through?
Yep,
Yes.
Okay, great. So here we have a first pass rough model with the aim of predicting acute renal failure in COVID patients. We would rather be doing this on ventilator usage, and we're working on clearing up the phenotype for that with Philip and the team at WashU. So hopefully we'll have a new iteration of this to show you shortly on that. But in the meantime, we went after this other outcome. So essentially, we had about 7,000 patients in total. About 1,200 of them were positive for COVID-19, and among those, around 300 had acute renal failure. And we aimed to use the safe harbor OMOP data here from WashU, from the labs and the conditions data to predict whether a patient would have ARF or not. We restricted the data for each patient to the data available 5 days before their first ARF event, so that this model would have some predictive value. And you can see as inputs, we have here the OMAP vocabulary tables, the safe harbor domains that I mentioned, all along the left side of the screen. So we essentially go forward, processing this into a feature table here, such that there is 1 row per person. And we have, for each lab, the minimum over the period up to 5 days before the ARF, the average, and the maximum. And then we also have the presence or absence of any set of conditions. And for conditions, we use the first 3 digits or characters of the ICD-10 code, so that we get a group of related conditions together. So at the end of the day, this first pass produces a model which actually has a reasonable AUC curve, certainly not perfect, but pretty good for the exercise and the data we have. We had to drop a lot of labs in which there were a lot of missing values. So not all patients had all labs, obviously. And so we had to drop labs that were relatively rare, which was a large number, as well as patients that had no lab data, which there were quite a few of. Then on the confusion matrix here, we see that the algorithm does do pretty well at predicting the absence and the presence of acute renal failure. So importantly, a big part of the reason for doing this, and the same thing with ventilator, will be to understand the features that the model is using, so that we can try to get some new medical and biological insight here. So these are the ranked list of features that the model is using. And you can see things that come from the ICD-10 codes, and I'll get into what these are in just a second, N40 and G47, as well as labs like the temperature, the creatinine, which is obviously closely related to acute renal failure, but this is 5 days in advance of the actual failure event. And all 3 versions were actually significant features here: the minimum value achieved, the average, and the maximum value. And then you can see a couple other labs here: glucose, sodium, and chlorine and chloride, and a variety of other features. And so the last thing I want to show is diving into what some of these ICD-10 prefixes are. So these are what's covered under N40, which was actually the top feature. Interestingly, not sure what prostate cancer might have to do with this, but that feature came up. Sleep disorders, and also hypertensive heart and chronic kidney disease. That seems to make a lot of sense. Happy to answer any questions about that. If not, we can move on.
All right, thank you, Andrew. So these are just a taste of what the the platform is designed to do in terms of creating derived data sets, doing transforms, developing code books and machine learning, and being able to generate outputs like this. So that's kind of at the heart of the demo, and this has been really a flurry of activity. I want to really thank those who've been part of the demo team. We still have a few more days to refine this, and it may change over the next couple of days prior to the demo on Thursday. But wanted to give everyone kind of a little visibility in terms of this activity. And want to also thank Washington University, who was able to get us this initial transfer that allowed us to start developing this.
I had just one quick question. You showed ICD-10 codes, but your bar graphs only had like a count of 1. Is that because there was 1 patient, or is that, am I interpreting it wrong?
No, what I did was ICD-10 prefixes. So because there is 1 row per ICD-10 code in there, there were 4 codes that started with, I-47, I think it was, and there is 1 row for each of those in the table. That's what.
Okay, I just wanted to make sure it wasn't a patient count.
No. Also, this data, the conditions were recorded in SNOMED, and I used the relationships table in the OMOP data to convert this to ICD-10, in case anyone's curious.
Hi, this is Rob Stark. So I'm actually a nephrologist. Can you go back to the confusion table? I just want to point out something. So first of all, congratulations on pulling the data in and having an analytic platform so you can do nice analyses.
Yep.
Yeah, so, okay. Yeah, right. So there are, so the x-axis, the y-axis is the number of, so there are 18 real cases, is that it?
Yes. So the problem is that there was a strong bias in people that had ARF for unfortunately not having lab data. So when we cut out the people that didn't have lab data, we were left with a lot fewer cases of ARF in our test set. This is not an ideal number of patients for building a model like this.
Thank you. I was going to comment on that. The only thing I will comment on, the numbers are small, but the models that we've seen in the literature have about 1 false positive for 1 false negative. I think I have that right. Essentially, they identify half the patients, and of the half that do get identified, only half of them actually have AKI. So the current models aren't very good. Being able to pull together quickly something in this environment with reasonable cases would be amazing. So thank you, but I would find a better example.
Yeah, and I think hopefully this even underscores the importance of aggregating data like this, because each center can do their own analysis, of course, but it's only by aggregating do we get the numbers and the power to do really interesting analysis. So this is, of course, the first site. I should add that we've had another, I believe there's over 5 sites that have signed DTAs, and we're working on transferring their data this week, and hopefully we'll have our counts up much higher even by the end of this week.
So Justin,
the prostate cancer doesn't help much, but yeah, go ahead. Sorry.
I was just mentioning, Justin, there are a couple of questions in the Q&A section.
And we're also getting, we have 9 sites that have signed, so that's great. Q&A.
Just the main question initially was around the Palantir training. People were just curious how many spots we'll have once the SSO is in place.
I think it'll be very similar to what we've been doing before, where we'll resume the fundamentals in a separate advance with multiple sessions per week and up to 12 people per session. So I think it'll be very similar. And I anticipate resuming some training next week. I just don't know the volume at this point. Looks like there's some other questions with respect to the model. Can you tell the differential effect of the important variables? I'm sure we could, Andrew. The question is do we want to go through that?
Yeah, I mean, a lot of these questions make sense for a model that you're really trying to build out and learn from. We just put this together last night, and so we haven't optimized the hyperparameters or looked at, and really many of the features that we would want to dive into. In part because we intend to. This is really just a demonstration of running a model on the patient data. It's not in itself supposed to be a finding. And as soon as we have the ventilator usage data, we plan to pivot to that as an example anyway, because we hope to have more cases of that outcome than we do for ARF.
Yeah, it's very preliminary. There are a lot of caveats because, as everybody's saying, it was really very much a demonstration that we could do it mechanically. There are obviously a lot of things that are highly related to AKI that are being included in the prediction, but it certainly was encouraging that the features that were important were things like creatinine and BUN. Not surprising, but encouraging that the thing is working.
So on that front, I would suggest we not dig in deep into the model. Again, we're kind of showing you warts and all how we're quickly assembling some workflows as a demonstration as opposed to a real clinical application. So hopefully people will be highly motivated to join the advanced training. They can learn about how to develop these workflows, build ML models, and I think once we get more data to the system, we'll be starting to we'll present some more clinical findings as we go along. Okay. So with that, why don't we move ahead with the presentation? I'm going to share my screen. And okay, so we're going to move forward with an OMOP overview. As I mentioned before, we had a very high-level Odyssey presentation of some of the applications. I think there's a number of people here who may not be as familiar with the OMOP Common Data Model, and so wanted to have the opportunity to take a deeper dive. So Claire, if you don't mind introducing yourself before moving with this presentation.
Sure, yeah. So my name is Claire Blacketer. I work for Johnson & Johnson. I work on Patrick Ryan's team. If you guys have heard his name before, he's one of the guys responsible for actually designing the first OMOP Common Data Model. And I do a lot of work with the data model on a day-to-day basis. But then my role in Odyssey, I actually help to manage the model itself. So I'm responsible for kind of taking input from the community and helping arrange that into potential updates to the model. And I do a lot of work around data quality, leveraging this model and how it works. So what I was hoping to go over with you guys today was really, talk a little bit about the tables. I won't go too in depth into each one of them. I'm not going to go over the fields and everything, but just at a high level, what is there, and then kind of a little bit about why we do it, and a little bit about the vocabulary, and then what it enables us to do. So what you're seeing on the screen is a list and an organized list of the tables in the Common Data Model. And you can see they're organized into standardized clinical data on the left. And so that's going to be all the tables that will have clinical events. We also have some things, some tables to save some things about the health system, so the care site providers, that sort of thing. Health economics, so some cost, which I don't think will play a role in these analyses necessarily, but it is available. We do have some derived tables, so those ERA tables in the purple box in the middle bottom. And then you also see the vocabulary tables there in the orange on the right-hand side. And we specifically include that in the model because as you've probably heard, we don't just standardize the structure of the data, but we also standardize the vocabularies. And so just kind of going through some of those clinical data tables, and I'll try to keep an eye on the questions as they come through. But if any of the panelists have any questions, please let me know. So you'll see up at the top left, you'll see the person table, and it is a person-centric model. So everything is pretty much built off of the person table. We require really only that the person table and the observation period table have any data in them. I don't know that anyone has built out an instance of the common data model with just person and observation period, but that is a valid choice. So observation period is meant to just denote the time period during which you can reasonably expect to find clinical events for a person. So thinking about EHRs, that might be a little bit more difficult to define, but in this case for COVID, I think it might be pretty straightforward, as it probably will be the earliest time you see someone in the EHR record would be the start of their observation period, and then perhaps the latest time you have a record for them would be the end of their observation period, and then within the span of time you could expect to find clinical events. So as you go down some things that are pretty standard among most models. So we have a place to store information about visits, otherwise known as encounters, procedures, drugs, conditions, measurements, all those things that are pretty typical across the models, as we've seen as we've started to look at PCORNet and ACT and I2B2 and Trinetics. One of the things that sets OMOP apart a little bit, just in the way that we've put this together, is that the vocabularies actually drive data movement. So we do standardize these vocabularies, and I'll get into that a little bit more. But one of the things that we found really helpful is when we standardize these vocabularies, we've actually kind of standardized where in the model they go. So for example, records that have a code that ends up in the condition domain, and you can see there on the right hand side there's a domain table. So things that are in the condition domain, we can always expect to find them in the condition table, the condition occurrence table. Similar with procedure and drug and measurement. So in that way, we can all kind of start to speak the same language. And this is really helpful actually for Odyssey and for OMOP, because we have collaborators from around the world. And so when we standardize, and we, folks from Korea and the UK and France and Spain, we are literally speaking different languages. When we start to standardize these things and we put them all in the same place, we can then start to build out our standardized analytics, because we know where to look for those same records every time, if that makes sense. All right, so you can go to the next slide. So this is just a quick example, and this is pretty much what you guys are doing, except you're bringing the source data in first, and then you're going to be converting it. But you can see what it really helps us do. So if you have all these different sources, say from electronic health records, administrative claims, and maybe a registry, you can transform them all to the CDM. And then what that starts to allow us to do is build out some open source analytics, open source tools that then allows us to generate our evidence. And one of the things that I really love about the common data model is because we know the structure of the model to expect, we know where to expect to find records, as I was saying about that domain movement. So I always know what will be in the condition table. I'll always know what should be in the drug exposure table. Because we know what to expect there, and it's all standardized, we actually can move very far with our analytics, because we're we're only working on that one model. And I think many of you who work with PCORNet and I2B2 and the other models have probably experienced the same thing. It's very helpful to have this standardized base, the standardized model to then build on. And one of the great things about OMOP and Odyssey is that all of our tools are open source. And anyone can download them, but and just as importantly, anyone can collaborate and make them better, which I think is one of the things I love most about Odyssey. Okay, so let's go to the next slide. I'll talk a little bit about the vocabulary hierarchy. Okay, so there's a lot going on this slide, but essentially what I'm just trying to show here is how we start to standardize our codes. So at the bottom, you see a list of source codes, and these are typically codes you would think of as condition codes. So ICD-10, ICD-9-CM, SNOMED, but there's also READ, which is a vocabulary from the UK. OXMIS is also from the UK. We've got some mesh terms thrown in there. And you can see there, the arrows are pointing from those source codes into SNOMED CT. So within OMOP, we use SNOMED CT to standardize our condition codes. And some others, there are some procedure codes that are standardized as well. But we map them all into SNOMED, and from there we can also use SNOMED as a classification, because SNOMED has a really great existing hierarchy that makes it really helpful when you're starting to create those concept sets or code sets, and it can be really useful to start with one idea, and then you can start to walk up the hierarchy or down the hierarchy depending on the level of granularity you need for your specific project. So it's actually very, very useful. And we also have some MEDRA classifications in there as well that sit on top of SNOMED, just as another way to classify these codes. It's a pretty quick overview. Any questions about that before I move on? Okay, we can go to the next slide. I have something similar to show for drug concepts. One thing I forgot to mention, so we do not create these mappings ourselves within OMOP or Odyssey. So we get these from existing maps. Many of them for the US codes come from UMLS. That READ code vocabulary I mentioned, those mappings to SNOMED are managed by the NHS. And this is pretty similar for a lot of the major vocabularies that we're using. We just leverage existing mappings. And there is a way, you know, of course, everything is collaborative. So there is definitely a way that if you find something that you know, don't agree with a mapping, or you think that, you know, perhaps this is misrepresented, we do have a GitHub where we log those issues, and the vocabularies are updated very frequently, and pretty much as soon as, you know, say UMLS puts out something new, the vocabulary team picks it up and incorporates those new mappings and codes. So I think we had COVID codes in our vocabulary by early March, and we're continuing to add any that come out. I think the most recent were LOINC codes for COVID and coronavirus testing. So now this slide is an example of our drug mappings. So we use RxNorm as our standard drug vocabulary. And again, you can see at the bottom all those source codes that map into RxNorm. You know, we've got Multum, OXMIS, GemScript, NDC, pretty much any drug vocabulary you can think of, we've mapped them in here. And then we also have some procedure drugs. So those HCPCS and CPT4 codes that are used for, you know, those drug injections, those we've also mapped into RxNorm, and they can be identified by their ingredient. And so you can see we have a similar hierarchy for drugs as we do for conditions. And all of these drugs, as they are mapped into RxNorm has that really great hierarchy that also maps them up to their drug ingredients, which is really helpful. And then on top of those drug ingredients, we have all these drug classes as different ways to classify drugs. So there's a lot to choose from there, especially when you're performing some sort of analysis. Occasionally ATC is a little better at one classification than ETC. As you know, they can be a little subjective at times. So we've tried to incorporate as many as are out there to help understand how drugs could be grouped together. All right, so that's about it. Just a quick overview of vocabulary. So if you want to go to the next slide, I have a little example of how this might work. So again, there's a lot going on this slide. I apologize for that. But what you can see here is just an example of standardization. So I've got 4 records from 4 different databases here. CPRD at the top is a UK primary care database. Optum is a US claims database. Premier is a US hospital billing database. And then JMDC at the bottom is a Japanese EHR database. So what I've shown here is like a shortened version of the condition occurrence table. Again, I didn't really want to go into all the fields, but just want to give you an idea of how the standardization works. So within OMOP, within the model, we not only standardize the codes to the condition concept ID, which you see on the far right, but we also contain all the source values as well, which is that middle column there. So I want to just show an example. So the middle column, you can see 4 different ways of representing acute non-ST segment elevation myocardial infarction. So you've got that G307 code, and then in CPRD and Optum, and then in Premier you see that I21.4, and then in JMDC it's I214. So it's 3 different ways of representing this clinical idea, and then you can see we've also mapped it to a source concept ID. So we have it's a standard way of representing those source codes. And the reason we do that is because, of course, the number I214 might mean something different in ICD-10 that it does in, maybe Reed has a code for I214 that means, live birth or something like that. So the source concept ID is the way we represent the source codes, and then those source codes then are mapped to one condition concept ID. And so this just kind of gets to that idea of us all starting to speak the same language when we talk about an acute STEMI. I don't have to look for those 3 different ways of representing a STEMI. I could see it here in that far right box with the condition concept ID. They're all mapping to that one concept. And that is in the condition domain, which is why they're all in the condition table. So it's actually like it's a really, really nice way of taking these 4 different databases that have 3 different ways of representing a clinical idea, and now they're all using that one code, which is really, really nice when you start getting into it. And then I have just a quick example. So if you go to the next slide, so this is a really nice paper from Jamia, just showing how you can apply the common data model to many different observational health databases and start to visualize similar things across those databases. So if you go to the next slide. So this is just an example, 6 different databases. But then we can start to build out this type of visualization, standardized analytics, because we're all, they're all on that same model. All those standard codes are going to be in the same place. We can start to really dig into these databases. Now we can start to compare them because we've done that hard work up front, and we can reap those benefits in these analytics. So I'll stop there. Are there any, I was looking at the questions. So let's see, so the one I see that could potentially be relevant, any plan to incorporate or support HPO terms. What does HPO mean?
Human phenotype ontology.
So, okay, so I'm not sure that they may already be in there. I don't usually work with human phenotype ontology.
They're not,
Okay.
and there's, this is Andrew Williams. So I think there is some capacity for linking. There's been conversations about adding HPO to the officially supported set of vocabularies that are represented in OMOP, and I think N3C might present an excellent opportunity to test how that could and should work. So I think there's interest on Christian Reich's part, and Peter Robinson's been involved in some conversations about how we might do that and link existing vocabularies through HPO to well, for various purposes. So not yet, but maybe soon, I guess is the answer.
So if I could jump in real quick, this is Melissa. Hi, everyone. So I think it would be great if we could take an action item to have a small group work on that, because one of the things that we're really interested in supporting is, and we talked about this on the last week's call, is the translator interoperability and the use of some of those basic research knowledge graphs. Those depend a lot on more of the basic research types of terminologies, and the HPO and Mondo and a few others are really pivotal for that intersection. So because they are designed with interoperability with, even though they're clinical terminologies, they're designed with that interoperability in mind. So I think that would be a huge advance for both the Odyssey community as well as for N3C. So if anybody's interested, let me know. Maybe we could put together a small group to work on that problem.
I imagine, Melissa, there's going to be a conversation in this week's, the Friday afternoon conversation on the resources and tools call, where I think Peter plans to attend for the Atlas tutorial. I was planning to follow up on conversations we had just about exactly that, the role of HPO and linking to translator. I was speculating and wanting experts
wonderful.
to describe that. So great.
All right. And while it's not the human phenotype ontology, there is a group within Odyssey putting together a phenotype library to start to build out some of like the major phenotypes that we are interested in studying. I don't know if that at all plays in to what you guys are doing. If you, I also could go through a little bit of the vocabulary in Atlas. I could show you some of how those hierarchies work, but I don't know if we have time or if anyone would be interested in looking at that.
If we do have time, I think that makes a lot of the excellent material that you have covered more understandable in terms of how it actually plays out when somebody's doing the work of defining a phenotype or anything else. So
yeah. So do you mind, Justin, if I share my screen real quick?
Yeah, that's fine.
Okay, should be okay.
Stop. So if you should be able to present now.
Okay, so this is the Atlas tool, and I haven't been in all of these calls, but it sounds like you're going to have an Atlas tutorial coming up, so I won't go through all of it, but what I actually find really helpful is the vocabulary search functionality and how it helps you build out a concept set and subsequently a cohort. So I typically start with some sort of condition. I am familiar with diabetes, so I typically start with diabetes, but is there any other condition that you guys are interested in?
How about COVID?
Well, we could do COVID, but there's not a lot of data, so it's not that fun. There's not a lot of hierarchy, so it's not that fun. But let me just show you diabetes really quick, but unless there's like COVID's like kind of the outlier because there's not a lot of hierarchies. But so for example, like if I look for say diabetes, I typically look at, okay, there's a lot of options here. So the first thing you could do is say, all right, I put 250.0, which I know is diabetes and ICD-9. But if you see, there's some form of 250.0 in a bunch of different vocabularies, which is, they're all listed here. So I'm going to click on ICD-9 just to filter that down. And then there's still some things to choose from. So I'm going to say I want diabetes without mention of complication. I don't really care type 1 or type 2. I'm more interested in no diabetic complications. So I'm going to choose that. So this comes up and it tells me, well, it's a non-code, of course, because it's ICD-9 and not a SNOMED code. So what I can then do is find the concept that this maps to, the standard concept that this maps to. So I'm going to click on related concepts. And luckily, there's only a few related concepts, but the best way to find the mapping to a standard code is this relationship here, non-standard to standard map. So I'm going to choose that, and it gives me this SNOMED code. Now, this also has built-in functionality. So this is record counts, so counts across the 13 databases I have at J&J with this specific concept ID. And then descendant record counts. So this is the number of records that have a concept ID that is a descendant of this guy. So 491 million records and 778 million descendant records. That's pretty good. But I'm going to click on it anyway because I think there's some other hierarchies that we could take a look at here. So when you click on diabetes mellitus without complication, there's a lot here. So there's a couple different ways you can start to traverse the vocabulary. A really good one is you can use these relationships here. So what I tend to do is start with looking at the descendants of this code. Okay, so it gives me type 2 without complication, type 1 without complication, and then type 2 without retinopathy, because that one seems like it's a little bit by itself. But I probably, if I was looking for this in SNOMED, I probably wouldn't have known that one existed or that I needed to include it. So okay, that makes a lot of sense to me. So then the next thing I can do in this relationship hierarchy is I can choose its ancestors. So I want to go up a level and I want to understand what are the ancestors, because maybe there's a higher level ancestor that might be a little bit broader than just this code. So I'm going to take this guy. And now there's a lot of ancestors because this is looking at the MEDRA hierarchy and the SNOMED hierarchy. And these colors, all the colors mean is that the purple is that this is a classification, and that this is an actual standard concept. So purple is classification, blue is standard concept. But you can see these are pretty high level. Disorder of body system, 21 billion records, that's a bit much. So what I'm going to do is say, well, I only want those that are one hop up, one distance away. And then so the next highest ancestor is just diabetes mellitus. I'm still just interested in diabetes mellitus without complication. So I think I'm going to stick with this guy. And I'm going to click this little shopping cart, and he's going to start a concept set for me. So I'm going to go to my new concept set, and I've got this diabetes mellitus without complication. And what I'm going to do is I'm going to include descendants. So it's going to include, now it's going to look for those 3 codes we saw, type 1 without complication, type 2 without complication, and then type 2, or it's like type 2 diabetes without retinopathy or something like that. So just one of the things I wanted to show you, so it now includes these 4. So instead of just looking for this one without complication, if I use this concept set, it's going to look for these 4 concepts in my data. And then the really nice thing it does, it tells you, well, what source codes are included? Because I really started with that 250 code, but now I want to know, okay, what other source codes are going to be included if I use this concept set? So I've got 5 ICD-9s. So that makes a lot of sense. And then I've got 4 ICD-10s. So it automatically is showing me this interplay between ICD-9 and ICD-10. This is ICD-10-CM. Of course, there's just regular ICD-10, and there's a couple others that are going to be included. So read codes, for example, is that UK vocabulary I was mentioning, and this one has a few more than just those 4 or 5 ICD-9 and ICD-10 codes. But I didn't really have to think about it, and using this hierarchy and using these mappings, it just is going to go ahead and include all these codes for me because they're all going to map into these 4 concepts. And then you can start to build out some more things that you're interested in. There's some other, exclusions you can do, that kind of thing. But that's just like a simple way to show you how the hierarchy works and how you can start to make it work for you as you put those concept sets together.
Great, that was really helpful, Claire. There's a related question from Christophe Lambert. The Odyssey tool stack, we realized is very robust and does a lot of things that Palantir does not do. And so it is the focus of the resources and tools group to study how the Atlas resources can be integrated into the Palantir system so that you can leverage all the SQL that is generated, bring it into Palantir and have it execute there. But there's obviously more details to work out.
Yeah, and as just a bonus, let's search COVID and see what comes up. So there's a lot of things that have the word COVID in it. I think if we search SARS-CoV-2, it comes up. I'm hoping. Oh, well, darn. There we go. So didn't have anything here. Let's see which version I'm on. There we go. So this is the configuration tab in Atlas, and I need to be on the newer vocabulary. I was on an older vocabulary. So if I go back, coronavirus, it should bring up coronavirus because there are codes for coronavirus now in that March vocabulary. So we have coronavirus infection, and then there are SARS-CoV-2 codes as well. Oops, sorry. But this is an example of how you would search for it. Sorry, they're not like, it's not super clean, which is why I was like, diabetes is a little easier one to find. But they're not super clean. There we go. Testing for SARS-CoV-2. So there's a few of them here, and they've added a few more since this March 20th update.
And as I mentioned on a call, if you don't mind my mentioning this, Claire, there pretty extensive work has been done on COVID, not just who has COVID and been tested for it, but all kinds of related phenotypes that are relevant to studies of COVID in the study-a-thon that's been ongoing since late March. And so there are things that can be directly imported from an Atlas instance that was set up explicitly for that. So not just the individual concepts that Claire was going through, but concept sets and entire cohort definitions, and some of which have, or quite a few of which have undergone some significant examination to make sure that they are both clinically representative of what they're supposed to and understand their performance in capturing what they're meant to. And those, so there's a method for just bringing JSON objects in from one Atlas instance to another that can be leveraged by N3C.
Great. We only have a couple of minutes left, and I can keep this brief. Thank you again, Claire. That was a really excellent overview of OMOP. I suspect that now that we have data in the Palantir system, there will be many questions about how do I access this data. Well, as you well know, there's a number of steps to be able to grant access to the research community. Among them is having a DUA approved and in place, as well as a data access committee. The Portal and Dashboards group is responsible for operationalizing access. Dave, maybe we can save this for next time, since obviously we're not going to have all this in place by next week. So everyone will have to be patient, but maybe Ken, if you're on, if you can just give us a brief update of where we are with the DUA and when we think that might be ready for circulation.
Yeah. Today we had Lily, who's heading that group, is putting, we had our first meeting today with the Office of Director, the policy folks, and the security folks, and Chris Hammond and Adam Berger, and went well. We described what we wanted. They gave us some feedback. So we're hopefully, after their feedback, to give them a draft this week and hopefully hear back sometime this week also. And then hopefully moving towards a more finalized draft sometime in the middle of next week. So that's our goal, is to get this all done within 2 weeks.
Great, thanks, Ken. Okay, so with that, thank you, everyone. I guess we have time for any additional questions. I don't see any in the chat. Okay, why don't we go ahead and, oh, I see there's one Q&A. Does the DUA cover each institute or just PIs? Ken, can you comment?
I'm sorry, Justin, was that for me?
The question that we have in the Q&A is, does the DUA cover each institute or just PIs?
Well, we're still negotiating that, but what we proposed was that the DUA would actually cover a covered institution, an entity. But the investigation, the investigator, when they proposed to study, would go through the data access committee, if it was thought or they requested that they needed line level data of the limited data set, they would still have a local IRB that they're
Thank you.
Bye, everybody.
Thanks. Bye-bye.
Bye.